Download this code from codegive.com, link in the description below. OK, let's dive into asynchronous I/O, AIO, with AIO in Python, specifically tailored for what you might expect in an ECE 252, or similar, context, focusing on understanding the concepts and practical code examples. ECE 252 Context and Relevance. In courses like ECE 252, you're often dealing with systems programming, potentially involving interacting with hardware, network communication, or handling multiple concurrent tasks. Asynchronous I/O becomes critical when you want to avoid blocking the main program execution while waiting for I/O operations to complete. This is particularly important for real-time systems. Minimizing latency and maintaining responsiveness are paramount. High-concurrency servers. Handling many client requests without getting bogged down in I/O wait times. Embedded systems. Resource constraints necessitate efficient use of the CPU and I/O. Lecture 28, Asynchronous I/O, AIO, with AIO. 1. Introduction to asynchronous I/O. The problem with blocking I/O. Traditional, synchronous I/O operations, example reading from a file, sending data over a socket, block the calling thread until the operation completes. While the program waits, the CPU is idle, wasting resources. This can lead to performance bottlenecks, especially when dealing with many I/O bound tasks. Imagine a single-threaded web server using blocking I/O. When a client requests a file, the server's thread blocks while reading the file from disk. During this blocking time, the server cannot respond to other clients, resulting in poor performance. Asynchronous I/O, AIO, to the rescue. AIO allows a program to initiate an I/O operation and continue executing other tasks without blocking. The operating system handles the I/O operation in the background and notifies the program when it's complete. This enables the program to perform other computations or handle other requests while the I/O is in progress. Key concepts. Non-blocking calls. AIO operations typically return immediately after initiation, even if the I/O operation hasn't finished yet. They don't block the calling thread. Event loop. An event loop is the heart of an asynchronous system. It monitors the status of pending I/O operations and dispatches callbacks or coroutines when the operations are ready. Example: data is available to read, a socket is ready to accept a connection. Callbacks/coroutines. These are functions or code snippets that are executed when an asynchronous I/O operation completes. They handle the result of the operation, example: process the data that was read from a file, send a response to a client. Benefits of AIO. Improved concurrency. Handle multiple I/O operations concurrently without requiring multiple threads or processes. Reduced latency. Respond to events more quickly, leading to better real-time performance. Better resource utilization. Avoid wasting CPU cycles while waiting for I/O. Scalability. Build applications that can handle a large number of concurrent connections or requests. 2. Python's Asyncio library, AIO. Python's Asyncio library provides a framework for writing asynchronous code using coroutines and event loops. It's the standard library approach for AIO. Coroutines. Coroutines are a special type of function that can be paused and resumed. They are defined using the async keyword. The await keyword is used to suspend execution of a coroutine until an asynchronous operation completes. The await keyword can only be used inside async functions. Asterisk when you await an asynchronous operation, example await asyncio.sleep, 1, the coroutine yields control back to the event loop, allowing other coroutines to run. Once the operation is complete, the coroutine resumes execution at the point where it was paused. Asterisk event loop asterisk. Asterisk the event loop is responsible for scheduling and executing coroutines. Asterisk asyncio.get_event_loop, returns the current event loop. Asterisk loop.run_until_complete, coroutine, runs a coroutine until it completes. Asterisk loop.run_forever, runs the event loop indefinitely, processing events as they occur. 3. Key asyncio concepts and functions. Asterisk async def, defines an asynchronous function, a coroutine. Asterisk await, suspends the execution of the coroutine until the awaited object, usually another coroutine or a future, completes. Asterisk asyncio.sleep, seconds, a coroutine that pauses execution for a specified number of seconds. It does not block the event loop. Asterisk asyncio.create_task, coroutine, schedules a coroutine to run concurrently with other tasks. It returns a task object that represents the running coroutine. Asterisk asyncio.gather, coroutines, runs multiple coroutines concurrently and returns a list of their results in the order they were passed to gather. Asterisk asyncio.lock, provides a mutual exclusion lock for synchronizing access to shared resources in asynchronous code. Avoids race conditions. Asterisk asynchronous sockets asterisk. Asterisk asyncio.open_connection, host, port, establishes an asynchronous TCP connection to a server. Asterisk asyncio.start_server, callback, host, port, starts an asynchronous TCP server. Asterisk asynchronous file IO asterisk, less common with asyncio directly, third-party libraries like IO files are often used. Asterisk IO files, a library that provides asynchronous file operations. 4. Code examples. Explanation of examples asterisk. Asterisk my_coroutine asterisk a simple coroutine that simulates work by sleeping asynchronously. Demonstrates the async and await keywords. Asterisk main_basic asterisk shows how to create and run multiple coroutines concurrently using asyncio.create_task and asyncio.gather. Asterisk fetch_URL asterisk an example using IOT to perform asynchronous HTTP requests. IOT.client session is used to manage connections. The async with statement ensures that resources are properly released. Asterisk main_HTTP asterisk fetches multiple URLs concurrently using asyncio.gather. Asterisk increment_counter asterisk a coroutine that increments a shared counter. Demonstrates the use of asyncio.lock to prevent race conditions. Asterisk main_lock asterisk runs multiple increment_counter coroutines concurrently, ensuring that the counter is updated correctly. Asterisk handle_client asterisk handles an incoming client connection to the server. Reads data, echoes it back, and closes the connection. Asterisk main_server asterisk starts the asynchronous TCP echo server using asyncio.start_server. The handle_client coroutine is called for each new connection. 5. Asynchronous file IO with IO files. Since asyncio doesn't directly provide asynchronous file IO, you can use the IO files library. First, install it. Explanation asterisk. Asterisk iofiles.open, asterisk asynchronously opens a file. Asterisk await f.read, and await f.write, asterisk asynchronously read from and write to the file, respectively. Asterisk the async with statement ensures that the file is properly closed after the operation is complete. 6. Error handling. Asterisk use try, except blocks to handle exceptions that may occur during asynchronous I/O operations, example network errors, file not found. Asterisk consider using asyncio.wait with return_exceptions equals true to handle exceptions raised by individual coroutines when using asyncio.gather. 7. Best practices and considerations. Asterisk avoid blocking operations. Asterisk ensure that all I/O operations within your coroutines are asynchronous. Blocking operations will block the event loop and negate the benefits of I/O. Asterisk use asynchronous libraries. Asterisk use libraries that are specifically designed for asynchronous programming, example IOP, IO files, IO page, for PostgreSQL. Do not use standard blocking libraries within coroutines. Asterisk context switching overhead. Asterisk while AIO avoids blocking, there's still overhead associated with context switching between coroutines. For very short-lived tasks, the overhead may outweigh the benefits. Profile your code to identify potential bottlenecks. Asterisk debugging. Asterisk debugging asynchronous code can be challenging. Use logging and debugging tools to track the execution flow of your coroutines. Python's debugger, PDB, works with asyncio, but can be tricky to use. Asterisk synchronization. Asterisk when working with shared resources, use asyncio.lock, asyncio.semaphore, and other synchronization primitives to prevent race conditions. Asterisk cancellation. Asterisk use asyncio.task.cancel, to cancel a running coroutine if it's no longer needed. Handle asyncio.cancel letter exceptions gracefully within your coroutines. 8. Advanced topics, beyond lecture 28, but relevant. Asterisk asynchronous iterators and generators. Asterisk use async for and async def to create asynchronous iterators and generators. Asterisk custom event loops. Asterisk create your own event loops for specialized use cases, example integrating with other event libraries. Asterisk transports and protocols. Asterisk asyncio allows you to define custom transports and protocols for handling low-level network communication. In summary, asynchronous I/O with asyncio is a powerful technique for building concurrent and responsive applications. By using coroutines, event loops, and asynchronous libraries, you can avoid blocking operations and improve the overall performance of your programs. Remember to focus on using asynchronous libraries for I/O, handling errors gracefully, and synchronizing access to shared resources. Good luck.